NENOMATICA, where mathematics meets YouTube excellence. The addition and subtraction of powers. Welcome to our lesson on simplifying algebraic expressions with powers. Today, we'll work through several examples to master these important concepts. Let's start with our first example. Here, we need to find the value of the expression 7a to the power of 12 plus a to the power of 12 minus 3a to the power of 12 minus 5a to the power of 12. For this problem, we need to combine like terms. Let's create a rule box to remind ourselves of the principle we're using. Let's start solving this expression step by step. First, we factor out a to the power of 12 from each term to get open parenthesis 7 plus 1 minus 3 minus 5 close parenthesis times a to the power of 12. Next, let's calculate the value inside the parentheses. 7 plus 1 is 8, 8 minus 3 is 5, and 5 minus 5 is 0. So we get 0 times a to the power of 12. Finally, any number multiplied by 0 equals 0, so our final answer is simply 0. Now, let's move to our second example. Here we need to simplify 3 to the power of x minus 1 plus 3 to the power of x plus 3 to the power of x plus 1 plus 3 to the power of x plus 2. For this problem, we'll use the properties of exponents to express each term in relation to 3 to the power of x. Let's review the relevant rules. Let's rewrite each term. 3 to the power of x minus 1 can be written as 3 to the power of x times 3 to the power of negative 1. Then we have 3 to the power of x as is. Next, 3 to the power of x plus 1 is 3 to the power of x times 3. Finally, 3 to the power of x plus 2 is 3 to the power of x times 3 squared. Now, let's simplify each term. 3 to the power of negative 1 equals 1 over 3. So we have 3 to the power of x over 3, plus 3 to the power of x, plus 3 times 3 to the power of x, plus 9 times 3 to the power of x. Next, let's factor out 3 to the power of x from all terms. We get open parenthesis 1 over 3 plus 1 plus 3 plus 9 close parenthesis times 3 to the power of x. Now let's add these numbers. 1 over 3 plus 1 is 4 over 3, plus 3 is 13 over 3, plus 9 is 40 over 3. So we have 40 over 3 times 3 to the power of x. We can rewrite 40 over 3 as 40 times 3 to the power of negative 1. This gives us 40 times 3 to the power of negative 1 times 3 to the power of x. Finally, using the law of exponents, we can combine 3 to the power of negative 1 and 3 to the power of x. This gives us 40 times 3 to the power of x minus 1, which is our final answer. Let's look at our third example. Here we have 7 times open parenthesis a to the power of 4 close parenthesis to the power of 5 minus 3 times open parenthesis negative a to the power of 5 close parenthesis to the power of 4. For this problem, we'll apply rules for exponents of exponents and calculations with powers. Let's review these rules. Let's start by simplifying the exponents. For the first term, open parenthesis a to the power of 4 close parenthesis to the power of 5 equals a to the power of 4 times 5, which is a to the power of 20. So we have 7 times a to the power of 20. For the second term, open parenthesis negative a to the power of 5 close parenthesis to the power of 4. Since we're raising a negative number to an even power, 4, the result is positive. So this equals a to the power of 5 times 4, which is a to the power of 20. This gives us 7a to the power of 20 minus 3a to the power of 20. Now we can factor out a to the power of 20 to get open parenthesis 7 minus 3 close parenthesis times a to the power of 20. Finally, 7 minus 3 equals 4. So our final answer is 4a to the power of 20. For our final example, let's simplify a complex fraction involving powers. We have 11 times 9 to the power of negative 5 minus 8 times 9 to the power of negative 5, all over 4 times 3 to the power of negative 7 plus 5 times 3 to the power of negative 7. For this problem, we'll simplify both the numerator and denominator, then apply laws of division with exponents. Let's start simplifying. In the numerator, we can factor out 9 to the power of negative 5. This gives us open parenthesis 11 minus 8 close parenthesis times 9 to the power of negative 5. In the denominator, we can factor out 3 to the power of negative 7. This gives us open parenthesis 4 plus 5 close parenthesis times 3 to the power of negative 7. Simplifying, in the numerator we have 3 times 9 to the power of negative 5, and in the denominator we have 9 times 3 to the power of negative 7. Now, let's simplify the fraction. 3 divided by 9 equals 1/3. This gives us 1/3 times 9 to the power of negative 5 divided by 3 to the power of negative 7. We can rewrite 9 to the power of negative 5 as open parenthesis 3 squared close parenthesis to the power of negative 5 equals 3 to the power of 2 times negative 5, which is 3 to the power of negative 10. In the denominator, we can rewrite 3 times 3 to the power of negative 7 as 3 to the power of 1 times 3 to the power of negative 7, which equals 3 to the power of negative 6. Using the law of division with exponents, 3 to the power of negative 10 divided by 3 to the power of negative 6 equals 3 to the power of negative 10 minus negative 6, which is 3 to the power of negative 4. That completes our examples on simplifying algebraic expressions with powers. Remember these key principles. Combine like terms by collecting common powers. When dealing with the same base, add exponents for multiplication and subtract for division. For a power raised to a power, multiply the exponents. Always simplify fractions and expressions to their clearest form. Try solving similar problems on your own to enhance your understanding of these concepts. Welcome to our math lesson. Today, we'll be simplifying a complex exponential expression step by step. Let's break this down methodically to find the final result. Here's our expression. 25 to the x plus 5 to the 2x plus 1 minus 5 to the 2x plus 2 plus 25 to the x plus 1 minus 5 to the 2x. Let's start by rewriting all the terms using the same base. We know that 25 is 5 squared, so 25 to the x can be rewritten as 5 to the 2x. Also, 25 to the x plus 1 can be rewritten as 5 to the 2x plus 2. Now, let's expand the exponent in the fourth term. Using the property that 5 to the 2 times x plus 1 equals 5 to the 2x plus 2, let's group like terms. We have two terms with 5 to the 2x, one term with 5 to the 2x plus 1, and two terms with 5 to the 2x plus 2. Now let's combine the like terms. We have 5 to the 2x minus combine the like terms. We have 5 to the 2x minus 5 to the 2x, which equals 0. And then we have minus 5 to the 2x plus 2 plus 5 to the 2x plus 2, which cancel each other out. After combining like terms, our expression simplifies to just 5 to the 2x plus 1. So our final answer is 5 to the 2x plus 1. We have successfully simplified the complex exponential expression by 1. Rewriting all terms with the same base, 2. Expanding exponents, 3. Grouping like terms, and 4. Combining like terms. The answer is 5 to the 2x plus 1. Thank you for watching. I hope you now understand how to simplify expressions with exponential terms. Remember to always look for ways to rewrite terms with the same base and combine like terms to simplify complex expressions. Welcome to our mathematics video. Today, we'll work through simplifying a complex exponential expression using properties of exponents. Let's look at our example. We need to find the value of the following expression. Let's start by rewriting our expression. First, we'll express 9 to the x power in terms of 3, since 9 equals 3 squared. We'll also separate the various terms with different exponents to make it easier to work with. Now we can apply the properties of exponents. Remember that when we multiply terms with the same base, we add the exponents. So 3 to the power of 2x times 3 to the negative 2 becomes 3 to the power of 2x minus 2, and similarly for the other terms. Next, let's simplify the coefficients. We have 27 divided by 9, which equals 3, and 6 divided by 3 equals 2. Now we can factor out 9 to the power of x from all terms. This gives us 9 to the power of x times the expression in parentheses. Let's calculate the expression inside the parentheses. We have 9 minus 1 plus 3 minus 2 plus 18, which equals 27. We can express this result in terms of base 3. 27 is 3 cubed, and 9 to the power of x can be written as 3 squared to the power of x, which is 3 to the power of 2x. Using the power of power property, we can simplify 3 squared to the power of x as 3 to the power of 2x. Finally, we combine the exponents since we're multiplying the same base. 3 to the power of 3 times 3 to the power of 2x equals 3 to the power of 3 plus 2x, which gives us our final answer, 3 to the power of 2x plus 3. So we have simplified the given expression to 3 to the power of 2x plus 3. We used several properties of exponents, including the product of powers rule, the power of a power rule, and factoring common terms. Try simplifying other exponential expressions using these same properties. Our first example is to find the value of this expression, 7 times a to the 4th power cubed plus negative a squared to the 6th power, minus 3 times a squared to the 6th power plus negative a cubed to the 4th power, minus 5 times a to the 12th power. Let's simplify this expression step by step. First, let's use the power rule, which states that exponents are multiplied when a power is raised to another power. So, a to the 4th power cubed equals a to the 12th power. Negative a squared to the 6th power equals a to the 12th power. A squared to the 6th power equals a to the 12th power. Negative a cubed to the 4th power equals a to the 12th power. Now, let's combine like terms with a to the 12th power. We have 7a to the 12th power plus a to the 12th power minus 3a to the 12th power plus a to the 12th power minus 5a to the 12th power. This simplifies to 7 plus 1 minus 3 plus 1 minus 5, all times a to the 12th power. Let's calculate 7 plus 1 is 8, minus 3 is 5, plus 1 is 6, minus 5 is 1. So we get 1 times a to the 12th power, which is simply a to the 12th power. Now let's move on to our second example. 3 raised to the power of x plus 2, plus 3 times 3 raised to the power of x, plus 3 raised to the power of x minus 1. Using the property that a raised to the power, m, times a raised to the power, n equals a raised to the power m plus n, let's rewrite our terms. 3 raised to the x plus 2 can be written as 3 to the power of x times 3 squared. 3 raised to the power of x minus 1 can be written as 3 to the power of x times 3 to the power of negative 1. So our expression becomes 3 to the x times 3 squared plus 3 times 3 to the x plus 3 to the x times 3 to the negative 1. Now, let's factor out 3 to the power of x. We get 3 to the power of x times 9 plus 3 plus 1/3. 9 is 3 squared. 1/3 is 1 divided by 3, which is 3 to the negative 1. Let's simplify inside the parentheses. 9 plus 3 is 12, plus 9 plus 3 is 12, plus 1/3 is 12 and 1/3. So we get 3 to the x times 37 over 3. This simplifies to 37 times 3 to the power of x minus 1. Let's review what we've learned. We've seen how to work with exponents and algebraic expressions. Remember these key properties. For the power of a power, a raised to power m, all raised to power n, equals a raised to the power of m times n. For the product of powers, a raised to power m times a raised to power n equals a raised to the power m plus n. By applying these properties, we can simplify complex expressions with exponents. Welcome to our lesson on simplifying algebraic expressions with exponents. In this video, we'll solve 2 example problems involving exponents and learn how to apply exponent properties to simplify complex expressions. Let's begin with our first example. We need to find the value of the expression shown here. Let's start by simplifying the first term. We have 5 to the power of 2x plus 1. Using the exponent rule, where a to the power of m times a to the power of n equals a to the power of m plus n, we can rewrite this as 5 to the power of 2x multiplied by 5. For the second term, we need to simplify 25 times 5 squared to the power of x. Using the property that a to the power of b raised to another power c is equal to a to the power of b times c, we can rewrite 5 squared to the power of x as 5 to the power of 2x. So this term becomes 25 times 5 to the power of 2x. For the third term, we need to simplify 5 to the power of x squared. Using the same property, this can be written as 5 to the power of 2x. The fourth term, 25 to the power of x, can be rewritten as 5 squared to the power of x, which equals 5 to the power of 2x. And finally, 5 times 5 to the power of 2x is just 5 times 5 to the power of 2x. Now, let's look at what's inside the parentheses. We have 5 minus 25 minus 1 plus 5, which simplifies to negative 15. So our expression becomes negative 15 times 5 to the power of 2x. We can further simplify this as negative 3 times 5, which is negative 15 times 5 to the power of 2x. Using the exponent rule again, we can combine 5 with 5 to the power of 2x, giving us negative 3 times 5 to the power of 2x plus 1. Now, let's solve another example. We need to simplify the following expression. Let's start with the first term. 3 times 3 to the power of 2x plus 1. We can rewrite this as 3 times 3 to the power of 2x times 3 to the power of 1. For the third term, 9 to the power of x, we can rewrite this as 3 squared to the power of x, which equals 3 to the power of 2x. For the fourth term, 18 times 3 to the power of 2x minus 2, we can rewrite this as 18 times 3 to the power of 2x times 3 to the power of negative 2. For the last term, 18 times 9 to the power of x, we can rewrite 9 to the power of x as 3 to the power of 2x, giving us 18 times 3 to the power of 2x. Now we can factor out 3 to the power of 2x from all terms. This gives us 3 to the power of 2x multiplied by the expression in the parentheses. Let's evaluate what's inside the parentheses. 3 times 3 equals 9. 18 divided by 9 equals 2. So we have 9 minus 3 minus 1 minus 2 plus 18. Computing what's in the parentheses, we get 9 minus 3 minus 1 minus 2 plus 18, which equals 21. So our expression simplifies to 21 times 3 to the power of 2x. We can rewrite this as 7 times 3 to the power of 2x, which gives us 7 times 3 to the power of 2x plus 1. To summarize what we learned in these problems, first, we use the rule that a to the power of m plus n equals a to the power of m times a to the power of n. Second, we applied the property that a to the power of m raised to another power n is equal to a to the power of m times n. Third, we factored out common terms to simplify the expressions. And finally, we recombined the terms using exponent rules. These properties allowed us to simplify complex expressions containing exponents into much simpler forms. Working with exponents becomes much easier when you understand these key properties. Practice applying these rules to simplify different expressions containing exponents, and you'll develop mastery of this important algebraic concept. Welcome to our math lesson on solving exponential expressions. Today, we'll analyze two problems from the image and solve them step by step. Let's begin with our first example. We need to find the value of this expression. 8 cubed times 9 squared times 25 to the 5th power times the sum of 3 to the 6th plus 3 to the 6th. First, let's rewrite each term using its prime factorization. 8 equals 2 cubed, 9 equals 3 squared, and 25 equals 5 squared. So we can rewrite the expression as 2 cubed to the 3rd power times 3 squared to the 2nd power times 5 squared to the 5th power times the sum, which we can simplify as 2 times 3 to the 6th power. Now, let's apply the power rule for exponents, where a to the m to the power of n equals a to the m times n. So we get 2 to the 9th power times 3 to the 4th power times 5 to the 10th power times 2 times 3 to the 6th power. Let's now group like terms using the commutative property. We can group the terms with the same base together. 2 to the 9th power times 2, and 3 to the 4th power times 3 to the 6th power times 5 to the 10th power. Next, let's apply the product rule for exponents, where a to the m times a to the n equals a to the m plus n. So 2 to the 9th times 2 equals 2 to the 9th plus 1, or 2 to the 10th power. And 3 to the 4th times 3 to the 6th equals 3 to the 4th plus 6th, or 3 to the 10th power. Now, we can use another property of exponents to rewrite this as the product 2 times 3 times 5, all raised to the 10th power. Finally, we calculate 2 times 3 times 5, which is 30, raised to the 10th power. So our answer is 30 to the power of 10. Now, let's move to our second example. We need to simplify this expression. 8 times 2 to the power of x plus 4 times 2 to the power of x plus 2 to the power of x plus 1 plus 4 times 2 to the power of x minus 2, all divided by 16 times 2 to the power of x plus 1 minus 4 times 2 to the power of x plus 2 minus 2 times 2 to the power of x plus 1. Let's start by rewriting the expression to make it easier to work with. In the numerator, we can express 2 to the power of x plus 1 as 2 to the power of x times 2. Similarly, we can express 2 to the power of x minus 2 as 2 to the power of x divided by 2 squared, or 2 to the power of x times 1/4. Now, let's factor out 2 to the power of x from both the numerator and denominator. In the numerator, we get 2 to the power of x times the sum of 8 plus 4 plus 2 plus 4 times 1/4. In the denominator, we have 2 to the power of x times 16 times 2 minus 4 times 2 squared minus 2 times 2. Let's simplify the expressions inside the parentheses. In the numerator, we have 8 plus 4 plus 2 plus 1, which equals 15. In the denominator, we have 32 minus 16 minus 4, which equals 12. Finally, we can cancel the common factor of 2 to the power of x from both the numerator and denominator. This leaves us with 15 divided by 12, which can be simplified to 5/4. And there we have it. We've successfully solved both exponential expressions. Remember to apply the rules of exponents carefully and simplify step by step. This approach helps us tackle even complex-looking expressions with confidence. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.